everybody, and welcome to our AP Unit 6 review here at Cranky Calculus. I usually have my students do this stuff, but it's the long weekend, and they are kind of slacking. Some are. Most are doing great. Some are completely slacking. You know which ones you are. So I'm just going to cover this FRQ part. Student's going to cover the MCQ. This is going to cover integration, Riemann Sums, FTC. So let's just get right at it. This is a very common FRQ where they're going to give you a graph. So you can see right here, you can see the graph of f below defined from -2 to 5. It's going to give me two line segments between -2 and 4, and then g of x is this little thing right here, and that's from 4 to 5. It also going to tell us the integral defined function of h, which is the integral from 0 to x. So let's go ahead and do this and find out these values. So we have h of -2. All I'm going to do is substitute in the -2 into the integral. And what you're going to notice here is that the upper bound is smaller than the lower bound. So I'm going to negate this to switch this up. So put the -2 on the bottom. Ooh, I gotta fix that. -2 on the bottom, and then the 0 on top. I'm gonna find the area of this lower part right here. Please take note, anything underneath the x-axis, we're gonna represent with a negative sign. So this is gonna be a triangle that's underneath the x-axis with a height of 4, base of 2. So half base times height is gonna give me a -4. But don't forget about that negative in front from already reversing the bound. So this is gonna give me an area of 4. h of 2, again, just substitute out. This one's a lot simpler than the first one. It's just going to be this triangle from here to here, which is going to give me a 4. And don't forget your DTs, by the way. Like, don't be one of those people that forgets the DTs, because you could lose points. Or sorry, not earn points. h of 5. It's integral from 0 to 5 of f of t dt. Now, when we look at this one, we can use geometry to find the area here from 0 to 4. That's not an issue, but the issue is going to come with the 5 to 4 part. So I'm going to split this up as an integral from 0 to 4 of f of t dt plus the integral from 4 to 5 of f of t. And if you remember, that's actually what that g of x is right there. So I'm going to actually just copy down this 1/5 x square root x squared minus 16 dx, because those are mathematically equivalent, so I'm going to write that down. So when I do this, the first part of it's super simple here. It's going to be a triangle where got a base of 4, height of 4, so it's going to be 4 times 4 times 1/2. That's going to give me a 8. So this first part's 8. I'm going to leave it. I'm going to go in red here and do this u sub value right here, because I cannot integrate this as written, but I can do some u substitution here in order to integrate this. So if I let my u value equal the inner function x squared minus 16, I'm going to get 2x dx. So I'm going to divide both sides by 2. So I'm going to get half du is equal to x dx. And the reason I do that is I can get rid of that x and that dx, and this converts to just a u. So life is actually pretty easy. So we're going to go plus integral. I'll get to those bounds in just a second. I have a 1/2 and a 1/5, so I'm going to call that 1/10 root u du. I think it's it. It's not bad. That I can integrate. I say that now. You just wait. Then these bounds, go ahead and change these bounds. Because we're in u bounds, we can't have x bounds anymore. So if I substitute it in a 5, I'm going to get 25 minus 16, which is 9. So the top bound is now a 9, which is nice because I'm dealing with a square root. So like a square root of 9, that's a pretty clean number. And then if we do substitute a 4 in, we're going to get 16 minus 16, which is 0. So bottom bound is 0. This is not that bad. So now I can just evaluate red, which is mathematically equivalent to this blue up here, and I'm going to be good to go. So let's go ahead and integrate this square root of u. If you remember, that's the same thing as a little bit of side work. That's the same thing as u to the 1/2. So if we were to add 1 to that, we would get u to the 3/2. If we divide by that, that would give us over 3/2. So equals 8 plus. I still have the 1/10 out front. I'm just going to just leave it. I'll play with the numbers in just a little bit. And this is going to be times 2/3 u to the 3/2. Evaluate that from 0 to 9. Plugging in that 0 is super nice. You can just zero out. That 9 is also really not that bad. Can I simplify this a bit to be 1/15th? 1/15th, and this is going to be times 9 to the 3/2 minus 0 to the 3/2. 9 to the 3/2 is the same thing as square root 9, and then we're going to cube it, so it's going to be 27. So this is 8 plus 27 over 15, which is really a fantastic answer. You don't need to do anything from that. Like, you can just leave it. But I'll clean it up just a bit for you. So I think we can divide the top and bottom by 3. So 9/5. 49/5. Did I do any bad math there? If I did, just comment below and just tell me how bad I am. At least you're commenting. So go ahead, moving on here to B. So again, A, a little bit of u-substitution there. That was like the whole point of that FRQ, is to see if we can do some u-substitution. So you just gotta be able to read into it. So go ahead and find h prime of 2. So h prime of 2, it's important that h prime of x is equal to, if you use second FTC, plug that f in right there and take the derivative of x, which is just 1. So h prime is just equal to x. So h prime of 2 is equal to f of 2. What's the value at f of 2? Well, the height at 2 is 4, so this is, well, lots of 4s as answers. You're going to get 4. H double prime of 2 would be the derivative at 2. And the derivative at 2 is, we cannot find that because of a corner. So this is DNE because there is a corner at x equals 2. Therefore, f is not differentiable at 2. So I'm going to write that down. That's good enough for me. Moving on. What x values of inflection points, or the x values of any inflection points of h? So looking up here at h. So again, h is the integral defined function. So if I want inflection points, I want h double prime of x, which we just said is f prime of x from the previous problem. So we need to know when x prime changes signs. That's the same thing for inflection point. It's when h double prime changes signs. I'll write that down so we have it. Changes. I need to work my handwriting, I know. H double prime changes signs, which in our case is when f prime has relative extrema. You have, not f prime changes slope, but f has relative extrema. I caught myself on that one. Has relative extrema. So that's when f prime changes signs as well. But we can't talk about f prime because we're only given f. We must talk about f. So relating that back to f prime, if f has relative extrema, then f prime changes signs. So where do we have relative extrema here? We have relative extrema at 2 and 4. So h has a point of inflection at x equals, I think I said 2 and 4. I'll just go scroll back and check. Yep, 2 and 4. Because f has relative extrema at those points. All right, and then the last part is, a bit of candidates test here. And they like to throw these candidates test questions on these graphs. I think last year we had like 3 questions with candidates test on the operational exam. Find the absolute minimum of f on the interval from -2 to 4. So absolute minimum means that we need to know when f prime of x is equal to 0. So yeah, let's go ahead and do that. So f prime, this is f. I feel like I shouldn't have done this question for f, but we're just going to answer it as is because I clearly made an error here. So when does f prime equal 0 or does not exist? You know what? On the fly right in the video, I'm going to say this is probably supposed to be h. Just going to make that connection right here. Switching it up. So find the absolute minimum value of h of x. And this question will make more sense now. They would not ask f. My bad. If you're still watching, thanks first off. We need more views. So when h prime is equal to 0, that is when f is equal to 0. So when does f of x equal 0? F of x equals 0 here at 0 and at 4. So So we can go ahead and do our candidates test now. So we're going to have x values of -2, because that's an endpoint, 0, and 4, which is a critical point and an endpoint, and we're going to find these h values. We already found h of -2. How convenient was that? H of -2 was 4. H of 0, if I substitute a 0 into the h, you're just going to get no area, so that's actually going to be 0. So that's looking like a good candidate right now. And then for 4, I feel like we found that earlier. Oh, 4 right up here. That value is 8. So looking for the value. So the min value is 0, and heck, we'll just say this happens at x equals 0 just for giggles. So we have it right there. So sorry about that little type on that question. But hey, this is the FRQ, super common. So yeah, keep on watching, and you're going to get some great MCQ information from one of my fantastic students that I have.
Hey, different cranky classmate here, and we're going to go over some multiple choice practice for this unit. So first thing, we're asked to evaluate this integral. So the first thing I see is that I have a sine t being multiplied with the dt, and then I also have a cosine t up here. So this looks like a u substitution problem, where I can set u equal to cosine t, and if I take the derivative of with respect to t on both sides, I'll get du over dt equals negative sine t. If I multiply by dt on both sides, I'll get negative sine t dt equals du. And now that looks really familiar to our term up here, which it is. I can just rewrite du. If I just want to get this back, I can say negative du equals sine t dt. So now we can rewrite this integral. If I zoom in, we can rewrite it as e to the u, because I set cosine t equal to u, and then I set sine t d of t equal to negative du. So I'm gonna just write a du here and bring the negative sign outside the integral. Now if I evaluate this, I get, it's just treat it normal, like a normal e to the x. It's just going to be negative eu. And now I can plug back in the cosine t. And I'll get negative e to the cosine t. And don't forget, it's an indefinite integral, so you want a plus c. So that should be answer choice A here. Number 3, evaluate the limits of this. Okay. So x is going to 0, and I see here this is a definite integral, and the bottom bound is also 0. If you take the integral of anything with the same number, that is always going to equal 0. So I can rewrite this as, if I plug in a 0 up there to the integral, I'll just get 0, and then 2 times 0 minus 2 equals negative 2. And 0 over negative 2 just equals 0. The answer choice A right there. Next, which of the following integrals has a value of 0? So an easy thing to do here, instead of trying to evaluate every single integral, think of these graphically. Remember, the integral is just the area under a curve of a function. So for A here, this is the formula of a semicircle. You're going to want to memorize that. So what this would look like is a semicircle with a radius of 2, from negative 2 to 2. And if you look at that, that's literally our bounds. And we can see that this is always positive. It never goes below the x-axis. And remember, anything above the x-axis is positive area, and anything that would be under it is negative area. So there's no negative area here, only positive area, so I can eliminate that. Next, let's look at how B would look like. So that's the absolute value. And if you remember, the absolute value function looks like that. It's never negative. It's always positive. So therefore, by the same logic, even if I go from negative 1 to 1, I only have positive area on both sides. So I can also eliminate that. So from the graphs of A and B, I can just eliminate them off the bat. Part C and D, they're going to be linear graphs. So I'm just going to actually evaluate them. I'm going to do 2 to the negative 4 x plus 2 dx. Remember, it's like the reverse of power rule. So I would add to the 1 as the power to get 2, and then divide by the 2 to get 1/2. Plus, and then the constant makes more sense, just becomes 2x. If I do that from 2 to negative 4, I would get 1 over 2 times 2 squared 4 plus 2 times 2 minus, I'm just going to group it so I don't forget, 1 over 2 times negative 4 squared is still positive 16 plus 2 times negative 4. So I get 2 plus 4 minus carry over 8, and then also carry it over here. So a negative 8 becomes a positive 8, which this gets me 6, which does not equal 0. And then we can double check for part D by evaluating 0 to negative 1 of 2x plus 1 dx gets us x squared plus x from 0 to negative 1. If I plug in a 0, I literally just get 0 minus a negative 1 squared, which is 1, plus negative 1, which is negative 1, which is in fact 0. So 4 is D. Okay, question number 5. We're given a table of values of f of x, and we're trying to compute a midpoint Riemann sum over the interval using as many sub-intervals as possible. So, just to remind you what a midpoint Riemann sum is, if I have a graph, and if I'm doing it from 2 to 6, what I do, instead of, and let's say there's 2 subintervals, instead of finding the values at 2, 4, and 6, I find the values at 3 and at 5. And I use that value as the height of my rectangle. Over the width of the rectangle, being 2. So, if we're trying to do that with as many as possible, given this table, we can only look at values that are in between another value. So obviously I can't do it with 5. X equals 5. That's the first value. So I'm going to do 8, which would do between 5 and 15. Consider x equals 20 between 15 and 30. And x equals 32 between 30 and 40. And then now we're just adding the area of these rectangles. So I'm going to do 15 minus 5 times, not 8, I'm going to use the value at 8, which is 10, plus the interval from 30 to 15 times f of x at 20, which is 20, plus the interval from 40 to 30 of f of x at x equals 32, which is 15. And now I just compute. So 15 minus 5 times 10 is 100. 15 times 20 gets me 300. And then 10 times 15 gets me 150. So 100 plus 300 plus 150 gets me 550, which is our answer choice number D, letter D. Question number 6 here, we are given an infinite sum and are asked to find the integral that it's equivalent to. So this looks a little daunting, but this is just a Riemann sum. Remember when we were estimating the area under a graph using rectangles? Well, now we're just doing that with infinitely many rectangles. So if I want to convert all of this into an integral in the form of from a to b of f of x dx, Then I'm going to first want to start by splitting up where I just boxed into f of x of k times delta x, where k just represents, if we want to relate it back to rectangles, right? K represents the specific rectangle you're at right now. Delta x represents the width of that rectangle, which is the same for all of them. And f of x of k represents the height of each rectangle. So, what is delta x equal to? Delta x is written in the form of b minus a, that entire subinterval, divided by how many rectangles you have. So in this case, b minus a equals 2, because I know b minus a over n equals 2 over n. Now, what is x of k? X of k can be rewritten as starting from that a, that lower bound, plus delta x times k, not with the subscript of k, times k, meaning that for every k rectangle after a, that I'm increasing the x value by delta x. So if I look up here, I'm given that I have a 2 plus a delta x times k. So I can set this equal to 2 plus delta x k. And remember up here, if I know that b minus a equals to 2, and I know a equals 2, then b must equal 4. And if I know that this represents x from the original function, then now I can rewrite this as the integral from 2 to 4 of f of x of k, and here x of k is just being squared. Now, unfortunately, I don't see this as an answer choice. D is out, and part C has the right f of x, but the wrong subintervals. So I'm going to eliminate that answer choice. Now, I see these other two answer choices rewrote it with a 2 plus x. And remember, adding a 2 within x is the same as just translating that graph 2 units to the left. So translating it 2 units to the left would decrease my bounds to 0 and 2. X plus 2 whole square dx. And that gets me answer choice A. Question number 7. I am given a derivative and I have one f value and I'm asked to find the other f value at another point. Whenever you have the derivative of a function, you have one value of the function, but you don't know the other value of the function, this is just Fundamental Theorem of Calculus, which, to rewrite the formula, states that integrating the derivative from a to b gets you that original function at b minus that original function at a. So now just plugging in, I'm going to set a equal to 2 as the lower bound, 4 equals the upper bound. My derivative equals 1 plus x cubed. And I'm going to set this equal to f of 4, which we are solving for, minus f of 2, which is 1.5. So now I'm just going to do some algebra. F of 4 is going to be equal to 1.5 plus that entire integral. And when I plug that into my calculator, I get 12.242, which is the same as answer choice C. So yeah, that was our Unit 6 review. We hope you enjoyed this video with your cranky classmates. As always, like, subscribe, and don't forget to hit that notification bell to stay updated for our later unit review videos. And our teacher, being cranky and all, has asked to up the ante to 1,000 likes minimum for him to dye his hair blonde. I'm sure we can hit it though, and I'm sure we'd all love to see it. So thank you. Bye-bye.